Welcome everyone to today's webinar. We're going to wait just a couple more minutes for everyone to join us, and then we'll get started. For those who just joined, we'll wait maybe one more minute and then we'll go. In this session, we're going to cover key features and highlights from our GNAT Pro 25 release, and also give you a sneak peek at upcoming features in our roadmap for GNAT Pro 26. Please note that this event is being recorded. The link will be available via email after the webinar has concluded. You won't be seen or heard, but if you're not comfortable with the recording, I invite you to sign off now. I'm Tony Aiello. I'm Head of Product and Innovation at AdaCore, and I'm delighted that you're here to see what we've been up to. If you have any questions during the presentation, please use the questions box at the bottom right of your interface. We'll answer these questions live in the questions box or during the Q&A session at the end. Let's get started. We'll kick off with an update from Raphael on Ada language features in the GNAT Pro 25 release.
Hi everyone, I'm Raphael Amia. I'm lead of language design at AdaCore, and I will present to you what we worked on for the release in terms of Ada language features. So to start off, just precision about how new language features and experimental language features work in GNAT. You have two subsets of extensions. The first one, which is the curated subset of extensions, is enabled with the option, the flag GNATx. Historically, this flag is used to enable all extensions, but since the last release of GNAT, it is used to enable only the curated subset. And we have a new flag, which is called GNATx0, which is a superset of GNATx and will enable every experimental features. So we encourage people to use the GNATx flag and use the features that we consider stable enough to be used by our customers and are supported in our tools. And the GNATx0 is a preview. So the first feature I'm going to go over is the external initialization attribute. So this attribute is an attribute that can be used by programmers to statically embed content in your binary at compile time. So this is very useful for embedded users because it avoids painful encoding of data as aggregates, which some of you might have done in the past, because this is for the moment one of the only options. Or the other option that you have on native targets is to load assets from files at runtime, but that can be tedious. So this is a solution where you will annotate your code and you can initialize a variable, in this example, some file data variable, with an aspect, which is external initialization, and you pass to a file, and the variable will be initialized in the binary with the content of the file. the validity of the given variable is checked at elaboration via the tickValid attribute automatically, so that you don't have to do it. For the moment, this aspect only works for simple data types, basically arrays of built-in scalar types or character types, and that's all. Another feature that we put in the -GNATX flag and in the curated subset is dot calls for untagged types. So as you might know in Ada, dot calls or prefixed calls for tag types are supported since Ada 2005. And originally it was only added for tag types. And what we noticed is that this forced users often who wanted to use these features to use tag types, where this is not necessary if you only want to use the dot notation. So we extended it so that all primitives can now be accessed through the prefix notation. If you want this to work, it requires the first parameter to be of the type of the primitive. So in the example you see, we can call primrec, which is a primitive on a record, but it also works on non-composite types such as this integer type int, where you can call primint on it via the dot notation. Another feature that we worked on that we are particularly proud of is the notion of generalized finalization. It goes hand in hand with the feature described on the previous slide, which is extension of a feature that was originally reserved for tag types to all types. And generalized finalization is a bit the same. So far, user-defined finalization in Ada required the user to derive from the controlled base type, which is a tag type. This has many drawbacks. So the first one is memory overhead of tag types, because you have some kind of memory overhead due to the header of tag types. The other problem is if you need to use tag types, you cannot derive from root type, another root type than control, which might pose design problems if you use tag types. And finally, and most importantly, you might not want to use tag types at all, or you might not be able to because of a coding standard. And in that case, you cannot have automatic finalization. Another problem with control is that constraints imposed by the Ada reference manual make control types hard to optimize, and it's hard to make them fast on every target. And last drawback is that control types are too complex to be put in limited runtimes, which are very used by our customers. So every embedded runtime, most embedded runtimes don't support control types. So what we did is define a new feature, which you can access via the finalizable aspect, and which basically encompasses finalization completely. It allows you to define a few aspects on a few subprograms on a type. So initialize, adjust, and finalize, which are the same as in control types, and relaxed finalization, which will allow you to have relaxed semantics, which I won't delve into, but allow you to have less guarantees, but faster finalization. And thanks to that, I was not done. So thanks to that, what we did is redefine the control type in terms of finalizable. So basically, those new semantics completely encompass the semantics of control types. And so the way that you can use them on those types, on your own types, is as you see here, we have a limited private type file, and you can define the file type as being a finalizable and give a primitive to close automatically those types when they go out of scope. And finally, we are working on a big update on object orientation, which will include an update on the syntax for object-oriented programming to give you something that is closer to what exists in other languages like Java or C++, notably because primitives are scoped and you can define private fields directly on types. These are only two small examples of the feature we are working on, more to come in the near future. That was our highlights for Ada language features. I will now give the over to Paul, who will introduce GNATfuzz.
Thanks, Raf. So GNATfuzz is the latest addition into the GNAT Dynamic Analysis Suite. This product sits nicely alongside our existing solutions for coverage and test. So as a quick reminder, GNAT coverage is our coverage solution for Ada, C, C++, and we're actively working on a Rust solution at the moment. It supports multiple strategies for trace analysis from basic statement all the way up to MCDC, as you see in guidelines for things like DO178C. GNATtest is our unit test solution for Ada. It automatically generates test harnesses. It sits on top of a technology called AUnit. It also has some nice features like automatic stubbing generation. And as we're going to talk a bit more about today, it now supports the automatic generation of test cases for some Ada types. So GNATfuzz is a technology that works on the command line like all AdaCore tools, but is also directly integrated into our GNAT Studio IDE. So whereas unit testing is typically focused on verifying that your system behaves as expected, you're verifying your functional requirements. Fuzz testing is more about trying to find those nasty corner case bugs within your software. And it does this through the mutation of data at a very high rate and observing the behavior of your system as it's dynamically executing. The solution that we've implemented focuses on automation. It's recognized that fuzzing campaigns are complex to create. So we automate the generation of the starting corpus, the executing of the campaign, the generation of the harness itself. And as you can see on the demonstration here, we can also replay the test cases that we find or that the fuzzer finds generate crashes within your system. And then through the IDE, we can very quickly take you to the place where an unhandled exception was raised. New 425, we've added some advanced branch solving algorithms, namely a symbolic execution capability called SymCC and an input to state correspondence algorithm. Both of these techniques are used to explore more of your code when we're fuzzing it. And the idea here is that we will work out what test cases would need to be to take diverging branch conditions through a concrete control flow. So we can provide you with more coverage over your software as we're fuzzing. Another technology we've added recently is called TGen. It stands for Test Generator for Ada. It's got two primary functions. It's got an advanced marshalling capability, and this means that we can generate binary representations of Ada values in a very tightly packed format, which is highly suitable for fuzzing. And we can also use this technology to generate test cases, so objects of particular Ada types. The test cases that we generate are human readable. They live inside a JSON format. You can go in, you can edit them, you can read them, you can add your own. And GNATtest will read and execute those test cases. But GNATfuzz will actually read, mutate, and execute them. And then as it's running a campaign, any mutation that it determines increases coverage across the campaign, it will feed back into that test case. That triggers a response in GNATtest to go and grab the latest tests and pull them in. So you've now got these two technologies working together. GNATfuzz can utilize a GNATtest unit test campaign as a starting corpus, and GNATfuzz can mutate that data, detecting when a mutation increases coverage, and feed those results back into GNATtest. And of course, while all this is going on, GNAT coverage is going to run in the background and analyze the traces across the unit test campaign and the fuzz campaign. So the tools are all working in a nice way together within the suite. The sort of outputs you can get is the testing campaign is going to give you your verification results, your test analysis. Is your software behaving correctly against your functional requirements? The fuzzing campaign is going to give you a crash analysis, or it could be a vulnerability analysis. Is your system free of bugs within your software? And the coverage is going to give you the trace analysis, which will be dependent on what strategy you've gone for, whether it's statement decision up to MCDC and the other strategies that we support. Another thing we've been looking at quite closely is workflows within the dynamic analysis suite. One such example of this is Fuzz Everything. The idea with the workflows is to try and simplify the way we see customers using the tools, particularly within their own continuous integration pipelines. Fuzz Everything will identify all fuzzable subprograms within your project, and then it will loop through generating the initial starting corpus, the harness. It will perform the build, execute, run the campaigns, and provide a coverage over the entire project and generate analysis results for you. So what's next? There's a lot going on. We are actively looking at how we can utilize this technology to perform on-target fuzzing. We've got prototypes for fuzzing on cherry architectures, which are a particularly interesting microprocessor architecture that supports memory safety at the hardware level. We're also working on an MS Windows solution that will be available in the 26th release. GNATfuzz for C is being worked on. After that, we will start looking at supporting more languages with the fuzzing technology. Workflows is going to be a big thing. There'll be much more of them to come, and many more features. If you'd like more information, please have a look at the website, and the user guides for all of our products are available there as well. And I'm now going to hand you over to my colleague Joao, who's going to talk to you about advances within formatting for AdaCore.
Thank you, Paul. All right, I'll now introduce a new product, GNATformat. GNATformat is a state-of-the-art and opinionated source code formatter for Ada and Spark. So as you may have already experienced, using source code formatters brings benefits to your development workflow. Benefits such as consistent code style and improved readability, which reflects, as an example, in easier and faster code reviews. This is one of the goals of GNATformat, and additionally, it aims to perform better than its predecessor, GNATpp, which suffered from big maintainability issues. Therefore, for GNATformat, we decided that it would be based on a famous formatting algorithm called Prettier. And Prettier is the base of many other formatters for many other languages. As a result, it has a proven track record. It has been extensively tested, and it is language agnostic, which is a big plus since we'll be able to reuse it for other languages, for instance, the GPR language. But we also want to go further, so easy integration with IDEs is also a high priority. The officially supported ones are VS Code and GNAT Studio, but you can easily use any other editor that has a language server protocol client. Finally, GNATformat is designed to be used on CI pipelines, so you can always ensure that your code base is properly formatted. I'm now going to show you a couple of examples where GNATformat does a better job compared to GNATpp. In this first one, we have an if expression where we decided that the style that we want is to have each part of our if expression on its own line. This was something that we could never achieve in GNATpp, but it wasn't really a challenge for GNATformat. In this second example, we have an association, which GNATpp always breaks after the arrow. Again, something we're not able to fix, but fortunately, it's now fixed on GNATformat. And finally, and perhaps one of the most important features, it's support for new language constructs. In this example, declare expression. Very challenging and time-consuming to introduce this in GNATpp. So for GNATformat, we made sure that this is not an issue. This is very important because it allows the formatter to keep up with the language evolution and its new features, such as the ones that my colleague Rafael previously shown. So the 25 release of GNATformat was a beta release. For its first non-beta release, here are some of the additional features that we plan to add. The ability to format GPR sources, showing a diff between the current source file and its formatted version. And because we know that each of you might have slightly different tastes when it comes to style, the ability to customize it completely. That's all I have for GNATformat. And now back to Rafael, who will present GNATcheck from our static analysis suite.
Thank you, Joao. Hello again. So this time for the GNATcheck product. So what is GNATcheck? GNATcheck is a state-of-the-art code style checker for Ada and Spark. It has more than 200 built-in checks, ranging from coding style to feature usage to warning-like checks. It is based upon a technology that we developed at AdaCore called LKQL, which is a code query language which allows you to write queries on code. It is readily extensible by users because the LKQL language is interpreted. So basically, GNATcheck is an interpreter with a collection of checks, built-in checks that the interpreter can run. The result of that is that users can write their own checks or modify existing ones to fit their needs. Another enhancement that we did to GNATcheck is that it now supports autofixes. So users will soon be able to apply autofixes to their code for some rules. Of course, some rules don't apply. They don't have an easy or clear fix that can be applied, but for some rules, it can be very helpful. So what does the Kit query language look like? It's a query language that allows you to do queries on syntax trees. So here, I showcase a very simple example of check that will flag object declarations or component declarations, which are using an anonymous access type. Because in some code bases, basically, you might not want to use them. This is let's say a coding style rule, because anonymous accesses have strange rules in Ada. They use dynamic accessibility, so forbidding them is not necessarily a bad idea in some cases. So what we do is check the type of node passed as an argument, and we are going to look for every node that is an anonymous type decal, and which has a parent that is either an object declaration or a component declaration. And we want to check that the type definition of the anonymous type decal is a type access definition, which corresponds to the kind of construct that we want to match. So this was for a very simple check. The query language is using libadalong, so every node type and construct that is used here is documented in the libadalong documentation. So this is for more complex check that also has an autofix. And the autofix is trivial, which is why I added it here. So this check will flag exception handlers that contain array statement with no exception name as the first statement, with some rules on top of that. So basically, exception handlers that you might want to get rid of. And in that case, the fix is very trivial, as you can see. It is passed in the @check annotation at the top. And it is a function, an anonymous function, where you will just remove the node that has been flagged via the context.remove operation. So this is documented in the GNATcheck reference manual. For the moment, we don't support users writing their own autofixes because the feature is to be released in 26. So for the future, what we want to work on is some future features for GNATcheck. The first one is for the LKQL language is a type system, because we are starting to have a big code base of LKQL checks. And another thing that we want to work on is a language server so that it's easier for us and for clients to write custom checks. Because as soon as you have a type system and a language server, you can leverage the tool to tell you what operations are valid on a node type, etc., etc. Another thing that we are working on is the integration of quick fixes in other tools. The command line interface of quick fixes is not yet defined, but we want to have one, and we want those to be available through IDEs, so VS Code and Gnat Studio. For those quick fixes, we are working on incremental reformatting based on GNATformat that Joao just presented, which will allow us to reformat the part of the codes that has been changed by the quick fixes so that we modify the user files as little as possible. And finally, we are working on a lot more refactoring-like rules which have quick fixes. And now over to Eli, who will present VS Code integration.
Thank you, Raphael. Hello, everyone. So Visual Studio Code is one of the most popular IDEs at the moment. And we provide an extension for that IDE, the Ada and Spark extension. The extension is available on the marketplace, on the Visual Studio Code marketplace. So directly from your VS Code instance, you can switch to the extensions tab, search for Ada, and install the extension from there. It's also available on Gnat Tracker, so you can pick it up from whichever source is more convenient to you. Something new this year is that we've decided to switch to a quarterly release cycle to follow up with the faster pace of features that we're adding nowadays. So you can expect a new release at the end of each quarter. Now, let's look at the new features since last year. We now have language support for GPR project files. So as you're editing your project file, you will get immediate feedback on syntax issues or other issues with your project. Over to the right, you can see we have completion of project attributes along with the documentation of each attribute. So in many cases, you no longer have to go to the GPR documentation to look something up. You can reach for the documentation directly in your editor. And finally, we have support for references across projects. So if you have a complex project landscape, you can navigate between your projects. The editor will help you do that. Another new feature is the integration of GNATformat. So we've just had a presentation of GNATformat from Joao. This is just to say that GNATformat is integrated in the VS Code extension. It's built in. You don't need to install anything more. It just works out of the box. Another new feature is now with the integration of GNATsas, the static analysis suite. GNATsas has supported emitting reports in the Sarif format for a few releases now. And we've leveraged that format to integrate with VS Code. Now you can load those reports, filter the messages, and navigate to the places that the messages are referring to. This leverages a third-party extension by Microsoft, the Microsoft Sarif Viewer, and we've integrated with that to provide that functionality. And finally, something I'm really excited about is the integration of GNAT-test. If your project has a GNAT-test harness, you can go to the testing view in VS Code and navigate to individual tests and run them individually. And perhaps most excitingly is you can run them in coverage mode and get a coverage report loaded in VS Code immediately after each test execution. And if you'd like and to have an aggregated coverage report, you can run all tests and get that. And of course, perhaps most importantly, you can, test failures are reported through the standard user interface. Those were a few of the most important features. There's a lot more going on. We also have support for debugging with Gnat emulator or directly on embedded targets. And if you'd like more details, you can go to the changelog on the VS Code Marketplace. I'd also like to give you an idea on the new things that we have in the pipeline. Our general goal is to make the programming experience as smooth and effortless as possible in VS Code. And so one topic we're working on at the moment is supporting or having the possibility of editing tests without having to switch to a harness project. And we're working on adding small programming helpers for the day-to-day, things like generating automatically a body stub for a new package spec or subprogram spec that you're adding, or extracting expressions into local variables. So stay tuned on those quarterly releases and give us some feedback. That was the update on VS Code, and now I'll hand over to Jose, who will give us the news on Gnat Pro toolchains.
Thank you, Eli. So, as you probably know, compilers are the cornerstones of our offering. And I am here today to give you an overview of what we support today, what is new in this 25 release, and what is coming, what the things that we are working on, so that you will have new things coming in the future. So here is the landscape of the things that we support. It's a multidimensional table. I will try to give you an idea about what it implies, what we support, so that you know what you can have. And obviously, there are things that are not reflected here. This is the main things that we have, but we have even more things than that. For example, we develop sometimes support for homemade operating systems. So if you don't find what you need or what you want here, just let us know. But as you can probably see, one of the dimensions is the languages, the programming languages. We support Ada and C on every platform that is in our portfolio. C++ is supported on most of our platforms, mainly when we don't support a C++ compiler in one of our supported platforms, is because the operating system vendor already has a good enough C++ solution. Otherwise, we used to have the access to the C++. And you can see Rust. I won't go into the details of Rust. Tony will let you know about what is going on in the Rust world. In terms of hardware, what kind of hardware we support? Typically, we support most of the hardware that is of interest to people working in the safety critical industry. So you see things like x86, of course, PowerPCs, ARMs, well, and many of them are coming. Most of them coming to the 32 and 64-bit flavor. So ARM, Leon 3 and 4 used in the European space, and RISC-V. Another axis of our support is the platforms that we support, and there obviously you will find both Linux and Windows, the widely used hosts for in the industry. You can have your Ada, C, C++, and even Rust development on a bare metal machine, no operating system underneath. And if you have an operating system of your choice, we support most of those that are widely available in the industry. For example, you have access to Lynx OS, to QNX, Artems, different flavors of VxWorks. So this is basically the outline of what we support today. Now, I will give you some ideas about what is new, what have been added during this 2025 release. In terms of targets, we have new targets on several of these axes. On the bare metal side, we've added support for Morello. Morello is an extension of ARM that comes with advanced memory safety capabilities. So if you want to benefit from extreme memory safety features, this is a platform that you may consider. Then we added to our offering support for FreeRTOS. The idea is to give you the possibility of developing your ADA code on top of a real-time operating system with a widely available set of drivers, so that you can interact easily with the external world. And then it's updates on operating systems that we already supported. For QNX, we now support the version 8. On the VxWorks side, we have added support to some new flavors like the Helix hypervisor. It is now supported in our offering, and some new versions of VxWorks 7, like the 2303 and 2403. Something that I didn't mention in the previous slide, this was another dimension that I didn't show, is the possibility of having different backends. We have had compilers based on GCC since the beginning, but for a few years already we have been adding new LLVM backends to complement our GCC offering, not to replace them, because the idea is to give you the choice so that you have both backends that you can use. So on the LLVM side, we already had support for Linux hosts, but now we support Windows hosts as well. On the embedded Linux side, we now support the 64-bit version of ARM, and same thing for 64-bit version of ARM. We support it on bare metal with the LLVM backend. And in terms of hosts on which we support these tools, we keep evolving, following the progress in the different hosts that are available to you. On the Windows side, you can use our compilers on top of Windows Server 2022 or Windows 11, of course. On the Linux side, we keep adding new releases of operating systems to our offering. Now we support Ubuntu 24.04, and we also support the possibility of using your Linux toolchain on a Windows platform via the WSL2 interface. And finally, on the Linux ARM based, we have access also to a Linux hosted compiler for that target. Now, this is the present. This is what we support today. Let's talk a bit about what is going on, what we are working on. This is not just to be clear, this is not an exhaustive list of the things that we are working on. There are more things, but I just wanted to highlight a few of the things that our technical teams are working on. I already mentioned FreeRTOS. FreeRTOS is today supported by our tooling, but it is supported today in a non-tasking mode. We're extending that support to add the tasking capabilities on top of FreeRTOS. On the On the embedded Linux side, we have easy access today. We will have an easy access to use embedded Linux on a x86 platform. There is a lot of work going on the LLVM side, and two of the main things that are being worked as we speak is the support for VxWorks. So you will be able to use VxWorks compilers for VxWorks that are based either on GCC or LLVM. And there is a strong push on the debugging technology, debugging support on top of LLVM. And finally, as I mentioned, we added support for ARM 64-bit Linux on the compiler side. You will be able to use Gnat Studio on such a platform. So that is what I wanted to tell you about compilers. I gave you a quick overview of of our offering, of what we support, a quick overview of what has been added in our release 25, so that you can now give it a try. And now this slide is about what is coming. So with that, I will leave the floor to Tony again for presenting our Rust offering.
Thank you, Jose. Let's talk about Rust. So Rust is a language designed for safety and performance. It's both type safe and memory safe. It supports concurrent and parallel programming, and it provides high assurance. For those of us who have been working with Ada for a while, these claims don't seem particularly unique. Ada is type safe. It offers runtime memory safety. Certainly, Ada supports concurrent and parallel programming and offers high performance. Rust has some advantages next to Ada. In particular, the memory safety offered by Rust is static. We pick that up with Spark, but with the base Ada, you don't get that entirely at compile time. Some of that's deferred to runtime. So there are some advantages in Rust. Rust is also favored by many developers. It's been ranked the most loved language for the last 7 years on Stack Overflow, something unfortunately we can't also say about Ada. So we see a lot of interest in Rust. There's a lot of community upswell around Rust, and that's something that we are definitely paying attention to at AdaCore. As we look into the future, we imagine that Rust is going to be a language that will be increasingly adopted for safety critical use. And we like this because Rust offers an opportunity, a kind of off-ramp, if you will, for folks who have been doing C and C++ for a long time, and perhaps who feel like Ada is a bridge too far. So we're certainly committed to Ada. That commitment is not going away. Ada will be a language that we push into the future as well, but now we want to offer Rust alongside Ada. So what is Gnat Pro for Rust? It's Gnat Pro available for Rust. Everything you love about Gnat Pro, we're trying to bring to the Rust ecosystem so that you can use Rust with confidence, just as you use Ada with confidence. We're leveraging our 30 years of experience supporting safety and mission critical industries now with Rust, just as we've done for Ada, Spark, C, and C++. We're available to answer technical support questions, and we're offering long-term support for Rust, which is something that the Rust project categorically does not do. So Gnat Pro for Rust is upstream Rust, but it's been stabilized and secured so that you can deploy it with confidence for your high integrity needs. Just like for Ada, C, and C++, Gnat Pro for Rust will offer yearly updates that will incorporate the best recent stable tested release from upstream. We build this release for you using AdaCore's reproducible build system. We build using only known versions of all dependencies, and we deliver this to you with an SBOM, with a warranty, and with the same service level agreement that you have available for any of our other tools. Additionally, we will backport fixes to critical vulnerabilities that occur within this year of support, just as we do for Ada, C, and C++. And if you opt for one of our long-term support products, we will backport even further so that you can continue to use the version of Rust that you've selected into the future with confidence. Again, this is something that the Rust project does not do. If you're familiar with Rust, you're aware that the Rust project releases a new version of Rust every 6 weeks, and that new version supersedes support for the prior version. So any fixes are only fixed in new versions. They are not backported to prior versions of Rust. What do we include in GNAT Pro for Rust? We give you Rust-C, the compiler. We give you Cargo, the Rust build and package management tool, GDB, the debugger. We give you GPR build so that if you want to do multi-language programming, in particular, if you want to do Ada Rust multi-language programming, GPR build is the vehicle by which you would do that. We give you Clippy, which is a Rust linter, and we give you Rust Analyzer as IDE support. This snaps into VS Code so that you can then continue to edit Rust code as you would have done were you using upstream Rust. The version of Rust-C that we're shipping today is 1772, and we have backported the fix for CVE 2024-43402, a vulnerability that was reported rather late last year, to 1772 so that customers that have selected that version can continue to use that version of Rust-C with confidence that they're not going to be vulnerable under that particular fixed vulnerability. In terms of libraries, today we give you libcore, libstd, liballoc, and libproc macro. Through Cargo, you can access any of the crates that are in crates.io, and those will work, provided they worked with the version of Rust that we ship, 1772. We don't offer support for those. We do offer support for the standard libraries listed here. Let's take a look at our roadmap. So right now, what we have available is native support for 64-bit Linux and 64-bit Windows. We have cross support for VxWorks 7 on 64-bit ARM, and we offer support for both DKM as a no STD target and RTP as a full target. And this cross compiler is hosted on both Windows and Linux. We also offer support for ARM 64-bit bare metal. This is a no STD target, and it's hosted on Windows and Linux. And finally, we offer support for cross Linux, ARM 64 Linux hosted on x86 64 Linux as the native host. Looking into the future, what we will ship, or what we plan to ship with GNAT Pro for Rust version 26, we're looking at version 1.85, certainly at least version 1.85, and that's going to give you support for Rust Edition 24, should that be important to you. In terms of new platforms, VxWorks 7, we're going to retool the RTP port so that it uses native APIs. Today, the VxWorks port is using POSIX APIs. We believe the native APIs will offer higher performance and will be a better fit for certification. We're also looking at QNX 8 on ARM 64, and we're looking at Lynx 178. In terms of tools, we will debut MCDC coverage for Rust as a component of GNAT Dynamic Analysis Suite 26. We're also looking at a coding standard checker for Rust that would be included in GNAT Static Analysis Suite 26. And I should say a word about custom ports. If there is a port that you don't see listed here that would be important to your adoption of Rust, you should reach out to us and let us know. As with AdaC and C++, we are ready and able to port Rust to custom architectures, to custom platforms, according to your needs, and we would be happy to provide a ROM for that. So that was Rust. Let's talk about AI at AdaCore. So there's a lot of hype around AI. And that's certainly not a new statement. It's been a lot of hype around AI for well over a year now. And the hype just seems to continue to build. The recent news around DeepSeek R1, for example, the recent proliferation of agentic frameworks that are offering quite compelling capabilities continue to drive this hype for AI. At AdaCore, we're approaching AI deliberately and thoughtfully. What we want to do is build solutions that work, that will meet the needs of your engineering teams, and that can be deployed on-premise or in private clouds. So today, what we're doing is finalizing our first offering and continuing to prototype to get a sense of what works and what doesn't, so that we really understand what's possible and what isn't. So there's two big things that we're looking at. The first is a capability that would help answer your questions. This is a fairly standard chat over docs system that is based on AdaCore's documentation and APIs. The goal of this system is to provide answers that are high quality, accurate, and backed by citations. And what we want to do is to make this available to you through GNAT Tracker. We also want to help accelerate your coding. We want to build an Ada and Spark code assistant that's customized for Ada and Spark syntax. We want to give you tools that are ready to use in your agentic workflows. And overall, we want to provide you with code completions that are high quality and useful. For both of these capabilities that we're working on, we want these to be optionally deployable on-premise or in private clouds so that you have the confidence you need that all of your data is remaining absolutely private. So let's talk a bit more about answering your questions. I want to stress that AdaCore will always provide you with expert support from real humans through GNAT Tracker. This is part of our fundamental DNA at AdaCore. This is not something that's going away. But sometimes you may have questions that are exploratory, hypothetical, potentially sensitive, or for which you think there's a really quick response and you're just not having any success at finding it. Our chat over doc system is meant to make it fast and easy for you to ask these kinds of questions and get useful answers. And then if it doesn't work, or if you need follow-up, you can always continue to ask questions through GNAT Tracker, and we'll jump on and provide you with support. In terms of accelerating your coding, as I said, we want a comprehensive code assistant that's customized for Ada and Spark. We want to be able to explain Ada and Spark code and explain error codes that come out of our tools. We want to offer you interactive assistance with writing Ada and Spark through high quality code completion and tools that you can use in agentic workflows. And here what we're trying to do is go above and beyond functionality offered by GitHub Copilots by giving you the ability to run these tools on-premise or in your private clouds. And that's because we understand that you have very sensitive development projects and you need tools that give you the confidence that your data is remaining private. In terms of roadmap, we're looking at initial limited availability of the chat over docs capability as part of a pilot program that we intend to launch in the second quarter of this year. For Ada Code Assistance, we're looking at initial limited availability in quarter 4 of this year. And as with many things we do at AdaCore, we're seeking to partner on AI-related research and development opportunities. So if you know of these internal to your organization or external, and you'd like to partner with us, please reach out. We would be delighted to discuss. That's AI at AdaCore. This concludes the webinar. So let's pause for a moment and we'll answer your questions. If you have a question and you haven't entered it yet, please go ahead and enter it into the chat now, and then we can now take these questions live. So we'll start out with a question from Joshua Cook. Joshua asks, is GNATfuzz not available on Windows yet? I was under the impression that it was.
So I can take this one, Tony. It's not. The underlying technology that we've used for the first version of GNATfuzz is an open source fuzzing engine called AFL++, which is primarily POSIX based. The version we're working on at the moment allows us to bring in additional fuzzing backend engines, and we are currently working on pulling in one that is actually an LLVM based fuzzer, and it will work on Windows. So this is going to be available in the 26 release, GNATfuzz for Windows.
Thank you, Paul. We have a question from Franco Monzanti. No more support for Apple systems? No, I'm sorry. Right now, Apple Silicon is not on our roadmap. We don't currently have plans to offer support for Apple systems. Luca Barbiero asks, is there a plan to extend support on RISC-V for more than bare metal software, but instead also for Linux?
I can take that. There is, as of today, we haven't had that much customer demand for Linux on RISC-V, so it's not part of the roadmap today. But it's always a question that we can always discuss on a case-by-case basis.
Mosa Nostratinia asks, will Zephyr RTOS be supported as a target?
Again, I can take that as well. The answer is very similar to the previous one, is that we haven't seen that much interest among our customers or people interested in our tooling. So no, it's not in the roadmap today, but again, something that we can discuss. We are used to do new ports on a very regular basis, so we know how to do it. It's something that we can do if there is enough interest, of course.
Nathan Laporte asks, hello, concerning the AI suite, would this take the form of a web app, or would it be integrated in VS Code and or GNAT Studio? So the chat over docs capability is a web app. And as I said, that's going to be integrated into GNAT Tracker. So if you have a question and you go to GNAT Tracker, you'll essentially have the option of, instead of opening a ticket, asking your question first to the chat over docs system. As for the coding assistance, I would say, yes, that will be integrated in VS Code and or GNAT Studio in some way. I can't answer that question with precision now because we don't quite know exactly what the form it will take. But we definitely want this to be something that you can access through your desktop in a very familiar way. We don't want you to have to be continually going out to a web app every time you're looking for coding assistance. Dagfinn Olsen asks, what are the plans for Android?
Okay, on Android, we already have a relatively old port that we have, and we are investigating what is needed to make an update. We have gone pretty far on that investigation, so we know what needs to be done. We have made progress on some aspects, so that is something that will happen soon. But I don't have a definite date today, but that's something that we are working on.
Kevin Dinkle asks, Ada Rust mix programming possible using bare metal Ada tasking runtime as main language and call into Rust libraries? Yes, this is possible. We have demos that we've put together where an Ada main is used to then call into Rust, and those results are passed back to the Ada code so that it can continue its execution. So this use case is totally foreseen. Of course, you would need to have Rust support on the same target as the Ada target. Rod Chapman asks, what plans do you have for formal verification tools for Rust? Today, none. That being said, this is an important and interesting area. There's a lot of active research that's going on here, and so we're watching that very carefully. Briefly, the reason I say today none is this is not the most proximate need for any of our customers who are looking to adopt Rust, but also it's still very early days for formal verification for Rust. The language itself is lacking key features that would be needed for us to want to move confidently in this direction. I'd be happy to take this offline and discuss further with any who would be interested in participating. We're at the top of the hour. I apologize to those of you who have questions who have not yet gotten them answered. Please don't hesitate to reach out to us by email. We would be happy to take those questions offline and answer them for you. Many thanks to all of our presenters, and thank you everyone for attending. If you signed up for today's session, you will receive a recording of the event and a follow-up email, so look out for that. And you can also download the slides now in the handout section. You can also read more about the features that we just covered in our recent roadmap blog. Thanks again, everyone, and have a great day.